So tonight, I'm going to talk to you guys about a project that 6 Feet Up has recently been working on. And as you find out, it's pretty interesting. So who in the room is using AWS currently as part of their corporate infrastructure? So quite a few people. That is really good because this will be interesting. The latest trends everyone's kind of talking about is the serverless. Who's using Lambda currently on their AWS? That's a couple people. Awesome. So even though it's serverless, there are still servers. I mean, the cloud is actually just other people's computers, correct? Someplace else, there's magical cloud, there's other computers. There's still resources that you have to manage. So everyone still has servers of some kind, and they still are resources, and they could be potentially expensive resources if you don't manage them correctly. So what I'm going to talk to you about tonight is a project called Cloud Custodian. It's actually an open source project out of Capital One. Some of you guys may have heard of these people, the What's in Your Pocket folks, you know, with the Vikings and such. If you guys have any questions along the way, please don't hesitate to stop me. Raise your hand. I'm happy to answer questions and make this as interactive as possible. But the current state of the problems are that a lot of these organizations, especially when it gets into the enterprise, and the kind of case for this is, you may have 3,000 developers and you want to unleash them upon the cloud. How do you do that in a way that doesn't cost you $1 bazillion, quite literally? You end up with a sea of policies, different kinds of scripts, handcrafted left and right, trying to basically put together these kinds of things. Fleet-wide savings policies. So if you want to be able to have on hours and off hours for all of your VMs, so maybe you've got developers who come in at 8 to 5, but outside those times, you really don't need to have those machines actually running. There's no good reason for it. So you can actually have policies around off hours to stop dev environments. If you're using EBS or ELB and you're not actually fully utilizing them anymore, being able to garbage collect resources like that so they can be put back in. How many people in the room have ever started up AWS resources on a Friday afternoon, come back Monday morning and realized you forgot to turn them off and had to pay for them all weekend? I literally did that yesterday. I had set up an RDS cluster, and I was so happy with myself that I had a read-only replica in Singapore. I was I've never been to Singapore, but I've got servers in Singapore. But then I got back in Monday, and I'm oh shoot, I left it running over the weekend. It was doing nothing. It was just running. It had nothing actually going on. Detect over-provisioned resources. So if you've got lots of idle time on servers, maybe you actually need to redeploy, kind of refresh your infrastructure at a lower level so that you aren't spending too much money on those resources. That's just the savings policies. You may have policies when it comes to security. How many people have an information security officer in their company? And those people are concerned with, are you using up-to-date images? Are you doing server-side encryption for at-rest data? Those kinds of things. Are you using correct SSL ciphers? Probably one of the trickiest things these days is to make sure you're up-to-date on the latest, which ones to use, which ones not to use. And then there's also compliance policies. Whether you want to have all your VMs, all your ELBs, all your resources that are up inside the cloud tagged appropriately. How do you enforce those things are actually happening? How do you actually fix them? Or how do you notify the people who are currently running those resources that they should fix them? And then how do you make sure you've got backups? You can actually, with policy enforce, you can write down a policy saying everyone should have their stuff backed up, but unless you've got something backing it up, like a person coming through and saying you should be doing these things and actually ensuring they actually happened, you don't have much power to make sure those things actually get done. Now this gets even more complicated when you start talking about fleet management. Who's using consolidated billing accounts on their AWS? If you aren't, you should be, because this actually will get you around a lot of the API limits. You can pretty much partition your applications off by business unit, give them their own AWS accounts, their own sets of security policies, but that adds to the overhead and complexity of managing an AWS environment. So what do we do about these ever-growing sets of tools? But then we have to look at how are these policies implemented. If we're looking at the fleet management or the consolidated billing accounts, how do you actually get into each of the various accounts, make sure they're implemented? How are these scripts that you may have to manage these things deployed? Where are they configured? How are they tested? who owns them, what groups are looking at them, how are they reviewed, do you have a code review process in place for these kinds of things? And I guess the question at the end is then who knows? Who really actually knows these things? There's a natural tendency to create very easy one-off scripts to manage something, especially with Python. It's so easy, especially with the Bot03 libraries. Well, I can write a one-off script. It'll just check in and look for old snapshots older than 60 days in EBS and delete them. Well, that's a one-off thing sitting over there now. This is where we enter Cloud Custodian. So Cloud Custodian is a, like the first title slide said, a real-time event-based compliance platform for AWS. So if all these issues I've kind of mentioned in the prior slides are right in the sweet spot for Cloud Custodian to solve, but they're not the only ones. There are lots of use cases that even the Cloud Custodian team who's working on the project haven't thought of. What's really cool about Cloud Custodian is it's obviously written in Python, or else I probably wouldn't be speaking to you about it. And it leverages very heavily the Bot03 framework. Very few dependencies actually in the project. There's actually a couple people in the room who are working on the project with us. Rob from 6 Feet Up and Scott is helping us out. I think the requirements file has 8 lines in it. It requires .txt. 7 or 8 lines. There's very few dependencies, which is really nice. It's a very clean, well-tested project. But that well-tested project provides a rules engine for you to apply to your AWS infrastructures, whether they exist across multiple regions or across even multiple accounts. So whether you've got consolidated billing and you've been doing multiple AWS accounts for each business unit inside your organization. It uses a YAML DSL, so you can see here it's a very nice human-readable YAML structure there. This is an example of one of the policies. So you write all of your policies in YAML, and then Custodian has built into it an integrated Lambda provisioning tool that takes that policy and converts it into a Python-based Lambda that can respond, in this case, to a CloudTrail event. So what this is basically saying here is we've made a policy called require RDS encrypt and non-public. It's using the RDS resources, so all the resources that are in AWS map up to Cloud Custodian resource tag keys here. In this case, we're using the mode CloudTrail, which says look for events coming off of CloudTrail. Specifically, look for the event called create DB instance. And then we have filters, which is the next step, so we can basically look for exactly the cases we're searching for. If it's not encrypted, and if it's publicly available, then perform the action delete and skip snapshots. So it's very easy to define that policy in a nice human-readable YAML format and have it deploy automatically. Running the Cloud Custodian command will actually run the provisioning into Custodian for us. And the best part about this, it is open source. So 6VF's been participating in the project. There are numerous other large organizations who are leveraging Cloud Custodian and producing pull requests and patches and issues and new feature requests for us. But you can actually go to github.com/1/Cloud Custodian and see the open source project. There's an issue tracker there that's very active. The manager or maintainer of the product is very involved in the day-to-day operation. We pretty much interact with him a couple times a week, and he reviews all the pull requests, well, in as timely a fashion as he can, reviews all the pull requests for us. Oh, so good. And gets, basically there's a nice community growing around the product. Capital One themselves has a few developers who are dedicated to the product right now. And I don't have a good client list in here. Actually, do you guys know who the big names are who are using Cloud Custodian? I can't think of it. It's on the, they have a nice .com corporate page for Cloud Custodian that shows off some of the big names that are actually using it. Well, Capital One, it's obviously a big one, but I think there's other ones like, if I recall correctly, I think Netflix and a couple others are starting to leverage this tool to basically provide compliance in the cloud. And it does it, again, through the CloudWatch events. So any event coming over that CloudWatch bus or anything that's CloudWatch metrics-based can be used as a filter to determine whether to perform some action. So not only can you detect that there's problems, but you can also potentially heal those problems. So for example, if you detect that there are S3 keys that are not encrypted, server-side encrypted, you can actually re-encrypt, tell the action to re-encrypt those keys and put them back into the buckets. The CloudWatch events gives us basically a nice top-down view as everything happens inside the infrastructure, which could be, depending on the size of your infrastructure. We were talking about buckets with billions of keys in them today. This works at that scale because it's dependent on events and not trying to actually pull and listen for or trying to figure out when new items happen. AWS has provided us a nice infrastructure to be able to do that for us, which is really handy. So all the CloudTrail events are available to us. Now there are different delivery windows for those events. And that's something you have to keep in mind when you're writing these kinds of policies, that not all of them are instantaneous. Here's a couple examples of those. For example, EC2 state changes, within 600 milliseconds. All CloudTrail events, you're guaranteed 99% of them to happen in 90 seconds of the delivery window. That was as of April of last year. Auto-scale instance membership changes, 600 milliseconds. You can also do periodically scheduling of CloudWatch events. So you can tell Lambda to run on a specific schedule, like every hour or once a day or bi-weekly, things like that, and actually use that periodic scheduling with custom timed periodic events to fire off. For example, maybe you're doing inventory and you need to report back on all the various resources you're currently using in your AWS stack. You can do that with the periodic scheduling and get reports back at any point in time with Cloud Custodian. And then you can actually fire custom events from your instances over the bus using the custom CloudWatch metrics and events systems, which is pretty handy. So here's so the CloudWatch, or the Cloud Custodian, is made up of these kind of core parts, which is the resource types. As each or AWS event happens, like reInvent or the summits, and they are always announcing new services that are out there, the CloudWatch teams have been pretty quick to add those into the latest tooling. So you kind of self-explanatory EC2 instances, AMIs, auto-scale groups, buckets, etc. I'll show later on in the slides how you can actually, from the command line, discover all the various resource types that are available and all the various filter actions that are available on those resource types, and then the various actions. So that's the next part, which is you basically would write policies for a certain kind of resource. You filter out explicitly for the items you're looking for, and then take actions on those filtered sets. So very straightforward with the YAML. And then you can output to JSON to S3, or even put metrics directly into CloudWatch, to CloudWatch metrics, and graph potentially results of various filters. So you could run these things periodically and graph, for example, how many ELB block storage devices you have mounted at any one point in time to an instance. There's all kinds of use cases for this that are beyond the scope of my brain. But they have the vocabularies of actions, filters for policy, or actions and filters for policy construction. Now, just to kind of give you an idea of how this all fits together as big puzzle pieces, no presentation wouldn't be complete without a nice architecture diagram. We currently store our Cloud Custodian configs in a Git system, and then periodically, or whenever there's a push into that, maybe you've got some kind of testing of the policy happening with a continuous integration environment, but they end up into your main Cloud Custodian host inside your cloud. You can then, in this case, this is an example of it's creating a Lambda function by running the Cloud Custodian to alert on real-time actions, and it can actually send out notifications. So if you have users starting up EC2 instances, and they're using an inappropriate or an older version of an AMI, what you may want to do is notify them via email that this has happened. So the owner of the EC2 instance can get automatic notification almost instantaneously as they launch an invalid EC2 instance. And then you can take action based on that. So you've actually also got the event triggers. So here we've got CloudWatch rules for watching for new EC2 instances being launched. We can write out our run metrics, so you can actually see how many times CloudWatch has run across the infrastructure and track number of runs, number of Lambda calls. But Lambda is not the only invocation method for CloudWatch policies. You can also run them via cron if you wanted to on your EC2 instances, so you're not limited to only Lambda invocation, but you could actually be running them as scheduled tasks on a dedicated EC2 instance, or even an instance that's not in the AWS infrastructure. And then logs can be deposited easily into S3 for later analysis. Any questions on this stuff so far? Kind of what the target of this project is? Yes, Scott. Sure, that's a great question. So for people who may not know what EC2 and S3 and RDS and all these TLAs that I keep talking about up here, they are the various resource types that are inside the Amazon Web Services cloud. So EC2 is the Elastic Compute Cloud. Those are basically virtual machines. It's kind of the main building blocks of the AWS clouds. S3 is it's a file storage. So you store objects inside of some kind of file storage. Think of it like a big filer. RDS is their relational database service. And there's, I don't know, I think I actually have a slide later that shows the whole list, well, maybe not the whole list because it's ginormous, of all the various AWS services that are available. Yeah. Yep.
So when you have a Git, then you push those configs up to the cloud custodian?
That may be an automated pull process from your continuous integration. So you may have tests. You can actually write test suites against your policies. And then you could pull only if there's success, for example. So it may be either a branch that you release into as part of your normal release process, whatever your Git workflow might be. But they're just plain YAML files. Each, you can organize them any way you want. One policy per file, or you can actually list out multiple policies in one file if they all relate to a single type of resource or a thing. It's pretty freeform as far as how you organize your policies. And then, storing them with version control is obviously a smart thing to do. Anyone else got a question about this? Yeah. That's a really good question. Does it do any kind of configuration history? So if you change, or if a security group were to change, you could detect the change. I don't know, Scott or Rob, do you know anything about I would think for example, if you change the security group policy, would it detect, can you diff and see that change? There's a dry run mode that'll show you what it will do, but I don't know if it'll show you the differences in the policy it would be affecting. It would say, I'm going to change X number of policies due to whatever you put into it. But I don't know if the logging would show you the fact that maybe you opened up port 80 in a security group. I'm not sure on that one. But it definitely would show you the number of resources affected by a policy as it ran, especially in the logging. So I just want to go over a few example policies to give you guys some ideas of use cases for using Cloud Custodian. In this case, we want to copy the EC2 instance tags to the block storage devices that are attached to our EC2 instances. So we're going to affect an EBS resource, and we're going to filter out for devices attached to our EC2 instance and where it's not null. So in this case, we're going to look for block storage devices, EBS devices inside of our AWS account that are attached to an EC2 instance currently, because you could have ones that are detached. If it is attached, we're going to copy the instance tags, and these specific tags are listed here. So it's going to look for those tags on the EC2 instance and copy that same value down into our block storage for us. So if you were to move an EBS volume from one EC2 instance to a second EC2 instance, and maybe some of those values were to change because you did that, Cloud Custodian would actually go ahead and correct those tagging policies for you, which is really handy. You can filter out by resources. So there are multiple ways of filtering inside of Cloud Custodian. There's a generic value filter where you can see, for example, like encrypted false. Right here is more of a generic value filter. You can have arbitrary nesting of filters with the ands and ors. So you can see here, if the app tag is absent and the environment tag is absent, and the encryption is false. So it's or on the first two and anded with the encryption being false in that second one for the filter. Simple key values are equality matches with value expressions. You can use, this is a James path expressions right here. For querying against the JSON return from the standard AWS APIs. So if you already kind of familiar with the structure of the JSON return from AWS, you can do some pretty sophisticated filtering based on that JSON. And in this case here, we're looking for tags that start with a key AWS with less than 10 of them. So or keys that start with AWS as they don't count toward the limit to filter those out. So you can get pretty sophisticated. There's lots of operator matching. You can do things like in or not in or absent, like we've got here, the absence of a tag existing, not null, greater than or equal to, or greater than. So there's lots of various ways you can actually filter and compare against values coming from the AWS infrastructure itself. Now, this is probably one of the more powerful features I like about Cloud Custodian is the ability to do multi-step workflows. So if you think about the fact that, or think about the situation where maybe a developer has started up an EC2 instance with an inappropriate image, or maybe they're not using the correct ciphers on a load balancer, for example, you can actually come through on each pass. Maybe you've got a scheduled pass at once a day, or actually in this case, it can respond to a CloudTrail event of a new EC2 instance being spun up. It can mark the instance as being out of compliance, give a grace period, and after that grace period is up, then perform some action. So you can actually give people some timings, maybe notify on the first operation, and then once that grace period has lapsed, you may want to shut down the EC2 instance, and then give another grace period of a day and terminate that instance permanently. So here's actually the example of doing that. Oh, it's really small. Shoot. And this is rendered as JPEG, so it won't work very well. So the first policy, and these are all up on my GitHub, so you'll be able to see these examples in code. But the first example is finding all non-compliant tag instances for stoppage for one day. So it actually does an operation, filters based on the absence of those tags. If the EC2 instances don't have the tag, it gives them 1 day of grace period to add the tag in. And after that 1 day, it comes back through and looks using the filter marked for operation. And if something is actually marked for the operation stop, it then will perform the actual operation of stop and then actually it's doing two actions right here. There's a stop action and a terminate action after 4 days. So there's kind of a compound action happening in the very last step, which is it's going to stop the instance after 1 day, and then actually marks it for operation again for terminate after 4 days. So you can see multiple actions happening in one policy there. Any questions about the policies? Let me make a step back real quick. Or the multi-step aspects here. Okay. Once you download Cloud Custodian to your local machine to play with it, it has if you do a pip install and get everything set up, you'll have a custodian command in your bin directory. And from the custodian command, you can use the schema subcommand to discover all the various resource types that are available. I'll show that in a minute. But if you actually explore further, you can use the schema subcommand and then the specific resource, and then view the actions that are available and all the filters that are available. So here we've got the auto scale groups, actions and filters listed, the EC2 filters and actions, or actions and filters listed, and same thing for S3. Some of the filters are going to be common across all the various resource types. So in this case, you can see like and is in all three. But then the actions, the EC2 and ASGs support the auto tag user, invoke Lambda, but the S3 has some custom actions, for example, as attach encrypt, or there's a couple other things in here that are very specific to S3s, where granting policies, delete global grants, are specific to that resource type. The documentation is getting better. We're currently working on that right now, but you can explore it by hand from the command line without having to necessarily dig into the code directly. So I've shown you kind of the EC2 and S3 and autoscale group types. We do have support for a lot of the various Amazon Web Services resources that are out there. These are just a couple of the example ones I put into the slides for ELBs, Redshifts, Cloud Formations. AMI should be its own bullet. block storage snapshots, so you can actually manage snapshot garbage collection automatically through Cloud Custodian. You may be setting up to do snapshots every night or every hour, and you want to be able to garbage collect them after a certain age. Cloud Custodian can go through and ensure you have compliance with maybe only keeping snapshots around for 60 days, for example. Oh, so if you want to see all the resource types that are currently supported by the latest release of Cloud Custodian, you can just run the schema subcommand with no actual argument, and it'll show you all the giant list of all the resources that are available. I don't have an exact number, but there's 30 or I guess 30 plus resource types that are supported by Cloud Custodian currently, which is nice. And as you run Cloud Custodian, you can actually get metrics put into CloudWatch metrics. So things like resource counts, action, how long a custodian policy took to run, query and filter times. We're currently working on adding in arbitrary put metrics into Cloud Custodian. So if you want to watch for a certain specific type of action or filter on a scheduled basis, and have it put arbitrary values into CloudWatch metrics, you can as custom metrics that are supported by CloudWatch. Here's another example policy with S3 encryption. So right now, it's really easy for you to require encryption on S3 buckets. So any new bucket that gets created inside of your infrastructure, you can tell it based on a CloudTrail event of create bucket, put in the policy of encryption policy and encrypt keys. So what it does is not only does it put in a policy that any new keys inserted into this bucket have to be server-side encrypted, but it also runs through any existing keys in that bucket. So maybe they created the bucket and put keys in it to it right away. It will go ahead and fix any keys that are currently in the bucket that aren't encrypted. So it's kind of that self-healing aspect of Cloud Custodian. You can select. So currently S3 supports AES 256, or you can use KMS keys, and you can use customer-provided keys. So there's 3 different kinds of server-side encryption keys you can use with the S3 service. Then, for example, here, encryption required policy on S3. This is an example of one that's running not in response to CloudTrail events that are coming through the bus, but actually at a scheduled rate. So in this case, once a day, we will run through S3 buckets that are of type isLogTarget, and we'll attach encryption policies, and we'll look for, what is this, remove statements of require encrypted put objects. So this just more than anything else is an example of using the periodic kind of cron-like functionality of Lambda, because this will still run as a Lambda. You can run these as cron jobs on your own servers. I think there's an efficiency benefit to doing that over, throwing them up in Lambda if you already had an EC2 instance running as a management machine in your infrastructure. So upcoming things for Cloud Custodian. Right now, Cloud Custodian doesn't have any kind of graphical user interface. All the interactions you do with Cloud Custodian are going to be via the command line interface. But we're looking at adding in Elasticsearch indexing of records and outputs. So you could actually build very easily some dashboards to view what's happened inside your infrastructure changes. Cross-language support. So right now we support Python 2.7. We're looking forward to them offering Python 3 as an option, but if you were wanting to write other language-based Lambdas as custom extensions to Cloud Custodian, that's kind of in the works. And we're always adding in more filters, actions, and resources. Again, here's the link to the open source project and the milestones specifically. I know we're currently actively working on 3 or 4 different enhancements to the product alone. I'm doing the put metrics one, so custom metrics being put into CloudWatch metrics. Scott's working on doing some templating of the configuration files. And Rob is actually working on some memory leaks with PyPy, sort of. Trying to. All right, any questions? Yeah.
Is there any plans to incorporate AWS configurables into this?
Not that I've seen. It's kind of on its own side project. No, some of the things Cloud Custodian overlaps with some of the features that AWS has been rolling out, but I have not seen us trying to leverage those specifically. I mean, have you guys seen anything with AWS, the AWS config product? Yeah, not that I've seen in our roadmap currently. Any other questions? Yeah, Alex. That's a good question. I think with the CloudWatch metrics, you can set up cost graphs. So you could have CloudWatch, or yeah, Cloud Custodian ensure that those are, your costs are being reported over into those metrics. But I've not tried that. I'm sure that's a common use case, but it's not something I've done with Cloud Custodian yet. Any other questions? Aaron. Now, the project is currently AWS specific. I think it'd be a pretty big effort to move this over to support other platforms, even though some of them are somewhat similar. They have kind of synonyms for a lot of these acronyms. But right now, it's AWS specific. Yeah? No, so it's all policy files run locally, and then wherever you save off your log files, based on the log files, you can do reporting. So, you know, every run generates logs, and then you have a custodian report command that will then go pull those logs and aggregate and give you reports. There's nothing else persisted on the system, is there, Scott or Rob? Okay, yeah, so there is some caching, but not necessarily nothing, you know, persisted as far as like data, other than just a cache of common AWS queries. Yeah, that's done with tags on the instances. So it will tag kind of, you know, custodian specific tags onto your resources, and then in subsequent runs it'll analyze those tags and use them for future runs. Yep. Yeah, exactly. You can definitely survive a kill and rebuild of anything here. Well, maybe your infrastructure can't, but Custodian will be okay. Yes, Sam. So this is heavily dependent on Bodo 3. So the projects themselves, all of our API calls are done through Bodo 3 directly, I think almost exclusively. So as long as the Bodo 3 library is kept up to date in the project, the API calls should all be safe. But yeah, there's definitely a risk of breakage as there's new releases. I don't know, I've not noticed any backward incompatible API changes to AWS. They typically will give you like a V2 version of some function so they don't break existing API calls that are leveraging an original implementation, like the S3 list keys or list objects inside of a bucket. There's a list objects V2 in the API. Any other questions? Awesome.